Welcome to Rges Algebra 2, Lesson 6.A, or Lesson 6A. We have switched books, and we are in 1.5, A and B today, and we're talking about solving equations, and you've done a lot of this kind of solving equations on your own already, so there isn't a huge amount to review with you for 1.5a. Let's just pick maybe, for instance, number 20, and this would say 4y plus 5y minus 1 equals 19. And so you would gather your like terms. 9y equals 19. You would take your 1, or your constant, to the other side by adding 1 to both sides. 9y equals 20. And then you would divide by 9. Y equals 20 over 9. And that does not simplify. And so that is your answer. I think those are very straightforward. I do want to review with you a little bit more what it looks like when we're solving inequalities. Recall the cardinal rule with the inequalities is when we multiply or divide by a negative number, in which case you have to switch your inequality. And the reason for that, of course, let's say we have two numbers. Recall greater than on a number line is to the right. Right? That's greater than. Okay, so if we have two values, let's say we have 3 and we have 7, and we know that 7 is greater than 3, because it lies to the right on the number line, but if we multiplied by negative 1 on both sides of the, which in this case is not an equation but an inequality, we would get negative 7, and if we left that inequality sign as it was, we'd say negative 7 is greater than negative 3, but that is not the case. And so we see that when we flip to the other side of the 0, because we have this mirror image phenomenon, the negative 7 is actually further away from 0 than the negative 3. And so the reality is that negative 7 is less than negative 3. And so that's the reason behind the rule, but you always have to remember to apply it. So let's say if we looked at something like, let's get one that's a little interesting here. That's not too interesting. This one, number 14, says 4x minus 6x is greater than or equal to 10. We combine like terms and we get negative 2x is greater than or equal to 10. But then when we're multiplying by a negative 1/2 to get rid of this on this side, right? We're multiplying by a negative 1/2, and that would be x is less than or equal to negative, and 1/2 of 10 is 5. So that's the kind of thinking we're looking at here. I don't think you'll have too much problem with that. Let's go on to 1.6. Let's talk these through. Number 1 says, what number multiplied by 3 is equal to 54? And that's very straightforward, because we would look at the verbiage, what number, and so we would say x times 3, what number times 3 equals 54. Of course, I would have been just as inclined, probably more inclined, to write that 3x equals 54 and then go ahead and solve it. Number 2, what number increased by 10? There's a number, we don't know what it is, so we'll let that be our variable. To increase means to add. Increased by 10 is equal to 19. And notice we're really just literally reading these off and translating from language into symbols. What number diminished by 30? There's a number. Diminished by means to subtract. We're having less than the original number. Diminished by 30 is equal to 20. and then of course solve it. Number 4, what number diminished by 45 is equal to negative 15? A little more complex to solve because of the negative sign, but not any more complex to come up with my equation. Number 5 is a little more complicated, though I think you've seen a lot of these in Algebra 1. We think of 3 consecutive numbers. We'll think of any 3 consecutive numbers. Let's say I have 1, 2, and 3. To get from 1 to 2, I add 1. To get from, let's go comparing to the original number, if we have 1 to 3, I've added 2. Okay, so if instead of 1 I have x, the relationship between that and the next one is x plus 1, and the relationship between the original, the x in this case, and the one next over would be x plus 2. So 3 numbers that are consecutive in order next to each other are represented by x, x plus 1, and x plus 2. So it says find 3 consecutive numbers whose sum is 42. So to make my equation, I'll just put x plus that, the 3 expressions, equals 42. And now for our last equation, it says find 3 consecutive odd numbers. Well, looking at the same logic I just used, let's say I have 1, the next odd number would be 3, and the next odd number would be 5. So what is the relationship between the 1 and the 3? I'm adding 2. What's the relationship between the 1 and the 5? I'm adding 4. So can you figure out then what my 3 expressions would be? It says find 3 consecutive odd numbers whose sum is 57. I would say x, that's my first one, plus the next odd one would be, this is odd because I'm just going to choose an odd, okay? This is would be to add not the next, not plus 1, that would give me an even one, whatever came next, but this would be x plus 2. And the next one that would be odd would be x plus 4. So hopefully that's very clear to you. If not, study that more carefully and bring any questions into class. So let's move on now to 1.7a. I did review this in class, but 1.7a has to do with multiplying multiplying by a monomial. Okay, so let's see, a monomial times a monomial. So let's pick something that maybe would be a little interesting. If I had m a n c b squared y squared, and I want to multiply that by m b to the b, n to the d, b to the x, and y to the b minus 1. So that looks kind of interesting. I need to only multiply together when I have the same variable as my base, right? So you have to combine them this way. Okay. We've already talked in class, if I were to multiply x squared times x to the 4th, this would be x times x, that would be x squared, times x times x times x times x, that would be x to the 4th. And the question is, how many are all together? And I have 6 altogether. So when we are multiplying variables with exponents, we add the exponents. And you can always go back to a little picture like this to make sure you know what you're doing. So following that rule, let's add my m's. A plus b. I can't combine those any better than that. Let's add my n's, c plus d. Let's add my b's, x plus 2. And my y's, kind of more interesting. I would add b minus 1, or I would add 2 plus b minus 1. Combining those, I'm going to get b plus 1. 2 minus 1 is plus 1. Okay? And so that would be my answer there. Now on the bottom part of 1.7a, which we have not assigned to you, it's just reminding me that an even number of negatives being multiplied together would lead to a positive, and an odd number of negatives multiplied together would lead to a negative answer. So let's look at one of those. Oh, I think I want to do number 13. It would say negative a squared x times 4bx times negative 5a squared. And notice I recognize that these are multiplied together because there is no sign between my parentheses. So I'm going to take care of signs first. Negative times negative is going to be positive, so I don't need to write it in. I could put a plus sign in front. Take care of constants next. 4 times 5 is 20. Take care of my a variables next. I've got 2 of them and 2 more of them. Adding exponents, I get a to the 4th. Take care of my b's next. I only have that. Take care of my x's next. I'll come down here. I've got 1 and 1 more. That would give me, and remember it's not, even though I say 1 and 1 more, I'm really multiplying. It's x times x, so that's x squared. And that's the way we do those kinds of problems. Finally, let's look at 1.7b. For this, we are multiplying a polynomial by a monomial. Okay, so if we have a binomial, for instance, let's say, let's look at number 2, negative L times 5w minus uv. This is a binomial, and I'm multiplying it by a monomial. I'm going to distribute. Now, even though I typically illustrate distribution over 2, a binomial, it could be over a trinomial, it could be over any number of terms. So recall how you do that. You take your negative L times your 5w. Typically we write our sign first, then our constant, and typically in alphabetical order. And then we're going to a negative for the second term. A negative times a negative is a positive LUV. So that would be the answer there. Let's see if I can find something a little more intriguing for us. Here would be kind of, number 10 would be kind of a medium one. Minus xyz minus xy plus yz plus 2xz. Okay, this is really not difficult at all. It just takes more deliberation. I'm going to have 1, 2, 3 terms when I'm done, the same as in the polynomial that I'm distributing my monomial over. So I'll have 3 terms. The first term is a negative times negative. That would be positive. X times x is x squared. Y times y is y squared. And don't forget your z from your monomial up front. Okay. For my second term, I'm going to then take this and multiply it here. Whoops. There. And so negative times a positive is a negative. I only have one x term. Y times y is y squared. Z times z is z squared. For my third term, again, I'm going to multiply that way. Negative times positive is negative. Take your constant first. X times x is x squared. I only have one y, and I only have, I have 2 z's, z squared right there. And that's the way you do it, just slow and deliberate. Something else that might cause a little bit of trouble for you, let's do something a little more complex. Okay, so this problem is number 15 in 1.7b. And again, I'm going to be very deliberate. I like to look at the lay of the land, so to speak, before I begin. And so here, if you'll notice, my lay of the land says I have 1 term, 2 terms. in my polynomial. So in my answer, I'm also going to have two terms. I'm just going to distribute my multiplication here and then here. Looking at A's, remember A's only distribute with A's. So in this first distribution, this part here is only going to affect the A portion over here because we only combine by variable. So here what I really have is adding exponents. I'm going to think like this. A, and then if I were to add all those exponents in my mind, I would go n plus 1 plus 1 minus n, just like that. You see where that's coming from? The exponent here and the exponent here. Okay, so summing that, and you can certainly do this in your mind, you get n minus n drops out, and you get 1 plus 1, or a squared. Now, these things do not have to be combined for my first term, because I have no b or c, but I do have to copy them down. So b squared c to the n minus 1. Now, to combine for the second term, here, again, I'm going to add the n plus 1 for my a's plus n minus 1. Now what happens there? Well, I'm going to get 2n, n plus another n, 2n, and my 1's will drop out. Now for my b's, I've got 2 for my exponents over here, and n minus 2 over here. So the 2's will drop out, and I'm going to get b to the n. And for my c terms, I've got n minus 1 plus, for my exponents over here on the monomial, right here. And then for the one I'm distributing over, I've got a 3. So that would leave me with n. 3 minus 1 is n plus 2. And that will be your answer. Okay, so again, being very deliberate, always adding exponents by variable, all the a exponents with a exponents, b exponents with b exponents, etc. And I think that's really all there is for the idea. Some of them get a little messy. If you need to write it down, like on a scratch piece of paper, feel free to do it, or go ahead and do it mentally. But be very careful, and I'm sure that you can get the right answer for these.